I'm Anil Kumar, and in this series, we are learning all about transformations, and I've taken up square root x as our base function. That really helps us to understand the techniques involved in sketching transform functions or writing equation of transform function from the given graph. The example before us is determine the equation of the transformed square root function. So that function which we are given here is a transformed function. We need to write equation of this particular function. Let us see how to do that. Now, as we know, this is transformation of the base function. So I'm calling that base function as f of x equals to square root of x. Even before beginning to find the equation, let us identify the key points on the base function and then plot it. Once we plot it, we'll get fairly good idea of what we are getting into. For a square root function, the key points are 0, 0, 1, 1. Square root of 1 is 1, square root of 4 is 2, and square root of 9 is 3, right? So these are the key points. 0, 0 is right there. 1, 1 means this point. 4 and 2 is there. 9 and 3 means this. So if I join these points, then I get the parent square root function, right? So that is my parent square root function. As we see, the function seems to have moved. The origin, for example, is a good point to always consider. So whenever you want to write the equation of transform function, what should you look into? So let's consider those points. First point which we should look into is always how the origin translates. So the starting point, or we can say initial point, which we should look into is the origin 0, 0 transformed point, or the image of 0, 0, right? So that is the first thing which we should look. Now this point clearly has moved 1, 2, 3 units left and 1 up. So from here, what we observe is it has moved 3 units left and 1 up. So that is kind of translation which we are looking into, right? So when we are saying we need to find equation of a transformed function, then transformed function means what? Means, let us say g of x is the transformed function. We want to write this as a times f of k times x minus p plus q. So we want value of all these points. So that 3 units left, 1 unit up means that p is minus 3 and q is plus 1. So we got 1 point. Now what is the next point to look into? So the next point to look into is stretch, horizontal or vertical, right? So what we can do is, normally we'll just consider the vertical stretch and imagine that the horizontal is 1, right? So even if there's a factor here, you could factor it out. That's the whole idea. To find the stretch from the initial value, so initial point to consider for stretch factor is 1, 1. See how this point gets transformed. So that means if you move 1 unit to the right, how much up or down you go. So in this case, if I go from here 1 unit right, I go only 1 unit up. That means here in this particular case, since it translates to a similar relative position, so we can say no vertical stretch or horizontal change, right? Horizontal stretch. So when I say stretch, I mean compression also. Is that okay? Stretch and compression is kind of similar things, right? So that means a and k is 1. So that means a equals to 1 and k equals to 1, right? And earlier we found the value of p and q. P is minus 3 and q is 1. Looking into this, we can definitely write down our transform function. So we can say g of x is equal to, we're calling this function as g of x, is equal to, the square root x is our base function, a is 1, right? So in square root x, what we have is a translation of 3 units to the left, which means x plus 3 within the square root, and 1 unit up means plus 1. So that is the transformation, correct? So that is how you get your transformed function. Now, to check, what we can do is, so we have here square root x plus 3 plus 1. So what we can do is, if that is the transformation, what should be my points from the original points? In every point, the x value we are taking away 3, and y value we are adding 1, right? So if I take away 3, I get minus 3, add 1 will give me plus 1. Minus 3 of this gives me minus 2, and if I add 1 to this, I get 2. Minus 3 of 4 is 1, and if I add 1, I get 3 here. Minus 3 is 6, and if I add 1, I get 4. So let us check if those are the points on our curve. Minus 3, 1, minus 3, 1, perfect. Minus 2, 2, minus 2, 2, that is also correct. 1 and 3, 1 and 3, that is right. 6 and 4, 6 and 4. So that is also a good check, right? So what we have done here is gone in a backward direction and showed you how we should be writing the equation, verifying it, right? So let's review what we have learned here. If you are given a transformed function, think about the parent function first, right? So fortunately, we are told here that the parent function is square root function. Anyway, so first step should be look for parent function. If you know the parent function, consider the key points to analyze. Now, it's a good idea to sketch the parent function also. Then you can literally see how the graph is moving, right? So that is why we have sketched this dotted line to indicate the parent function. Now it becomes kind of clear that it is a horizontal shift of 3 units left and 1 unit up. Based on that, you can write down your equation. Then it's a good idea to check with the points that the equation works for the transformed function. If you follow this process, you'll always get perfect equation of the transformed function. I hope that really helps. Thank you and all the best.